So modeling motion with parametric equations. Parametric equations are often used to model projectile motion. If an object is projected at an angle of elevation of theta, the horizontal distance and vertical position of the object can be represented by the following parametric equations. Okay, so if you look at this, it's like, oh, that's just a ton of variables, isn't it? So let's kind of pick apart what these variables mean. First of all, you see x for horizontal, which makes sense because x-axis goes horizontally, y for vertical, y-axis is vertical. All right, t. If we're talking about objects being in the air, what do you think t stands for? Time. V sub 0 is how I would read that. Anytime you see a sub 0, it means initial. So it's initial velocity. And it's sub 0 because initial is when time is 0. So that's saying the velocity at time 0. And then cosine of theta, theta is that angle of elevation that the object is following. Okay, for the vertical position, we have t again, that's time. V sub 0, that's initial velocity. Sine of theta instead of cosine. Minus 1/2 g t squared, there's time again, plus h sub 0. H sub 0 is the height at time 0, so we usually call that initial height. Now, what do you think g is? Gravity. As soon as an object is released or fired, it automatically, from the get-go, has gravity pulling against it. And so it's negative because gravity is pulling it downward. And G stands for the gravity value. Now, we use two different values for gravity. You might remember this from physical science. If we're dealing with meters, we use 9.8. If we're dealing with feet, we use 32 for gravity. So different units for the different types of measurement. And the problem will tell us whether we're dealing with feet or meters. So we just use the appropriate number for gravity then. Okay, so let's set up an example here. Example 1. Mark kicks a soccer ball upward from the ground with an initial velocity of 75 feet per second at an angle of elevation of 62 degrees. Okay, part A, we're just going to make a diagram of the situation. Okay, so here is the ground. We have a soccer ball, 62 degrees, that's pretty high, isn't it? Okay, so we have a situation where the soccer ball is kicked up at an angle here of 62 degrees. And naturally, the soccer ball is going to come back down, right? So eventually it will end up back on the ground. And then I'm going to make a note here. Initial velocity, so velocity at time 0 was 75. And notice that it's feet per second. I'm not going to put feet per second here because it's just going to look like some variables that actually aren't variables. But the fact that it's in feet per second tells me when I get to the gravity part of it, I'm going to use 32. Theta was 62. And that's all that we know. Oh, no, we also know the initial position or the initial height was 0 because it's starting on the ground. Okay, write the parametric equations to describe the horizontal and vertical position of the soccer ball at time t. Okay, so that's using these two formulas up here. Horizontal is the x. So x would equal time times initial velocity cosine of theta. So that's my horizontal equation for this situation. Okay, my vertical equation is the y equals, and it is t times initial velocity, 75, times sine of theta, sine 62 degrees, minus 1/2 times that pull of gravity. And again, because the problem is measured in feet, not meters, we'll use 32, t squared, plus initial height, which is 0. Now, believe it or not, that's a quadratic equation. I've got a t squared in there. So I'm going to rearrange it so that it's in descending order. What is 1/2 times 32? 16. So I'm going to have negative 16t squared plus, and I'm going to put this 75 sine 62 times t. And then technically there's a plus 0 out there. Okay, so I put my t squared first, then the t, and since all of this is multiplying it, I just wrote that as a coefficient in front of t. Okay, do you have to rewrite it? No, but we're going to do some problems in a minute where it will be easier if it's already written in that form. Okay, part C, find the horizontal distance the ball has traveled at 2 seconds. So 2 seconds after this ball has been kicked, how far away on the ground from the kicker has it traveled? So that means I'm just taking my horizontal equation, which was the x equals t times 75 cosine 62, and I'm subbing in 2 for time. So t equals 2. Gives me x equals 2 times 75 cosine 62. And we're just going to type that in our calculator. Be careful that your calculator's in degree mode, especially if you're using a graphing one, since we were graphing those parametric things the other day and polar things. So just check that you're in degree mode. And we have... You know what? Don't mistake that for 2.75. In fact, you might want to do this. Because that was 2 times 75. I almost typed in 2.75. That's why I said that. And I get 70.4. What would that distance be in? Feet. Just feet. Question.
Why would it not be squared? That's what we used.
Because it's just a distance. So.
Oh, wait, I was thinking about the gravity thing there.
Okay. All right. Any other questions on that one? Okay. Part D. Find the vertical position. So after 2 seconds, we know it has traveled 40 feet away from him on the ground, but how high is it? So let's calculate the vertical by using the y equals equation, and we're just subbing in 2. So I'll have negative 16, 2 squared, plus 75 sine 62 times 2. And these parentheses, let's just see what you get. I think we might need to talk about parentheses, but let's see. Did you get 68.4? Did anybody get anything different? Okay. Bless you. So it has gone 68 feet into the air. It's pretty high, 68 feet. Question on that. All right, next one. Do I have any tennis players in here? 2 of you. All right. A tennis player serves a ball at an initial velocity of 35 meters per second. The ball leaves the racket at a height of 2 meters at an angle of elevation of 45 degrees. So you're not hitting the ball from ground level, right? So initial height on this one is 2. The height of the racket. The initial velocity, v sub 0, is 35. It is in meters, so now when we pull in that gravity number, we'll have to use the 9.8. And theta is 45 degrees. Okay, make a diagram of the situation. Okay, so it is not leaving ground level. but it will come back to ground level, right? So 45 degrees is that angle right there. So you like consider where horizontal is, and then it's 45 degrees from horizontal. Okay, so that's the path that the tennis ball is making. Part B, write the parametric equations to describe the horizontal and vertical position of the tennis ball at time t. Okay, so horizontal, that would be our x equation. Look up at the top of the paper for your formula. T times initial velocity cosine theta. So that's how we'll calculate the horizontal change in distance there. In vertical is our y equation. At the top, t times initial velocity sine 45 minus 1/2. Since this is in meters, we'll use 9.8. T squared plus 2 for the initial height. Okay, and again, I'm going to rearrange this one. What is 1/2 times 9.8? 4.9. So I have negative 4.9 t squared plus 35 sine 45 degrees times t plus 2. Okay, part C, find the horizontal distance the ball has traveled at 1.5 seconds. So I'm taking my horizontal equation, my x equals, and subbing in 1.5 for t. $37.1, and this one was in meters. Question? Okay, part D, find the vertical position of the ball at 3 seconds. So now we're taking our y equation, subbing in 3. And let's see what we get. $32.2. Question?
Like, ask us to find like, what it is in feet if we do it in meters.
No, we won't do the conversion between feet and meters.
Where did
The
the 9.8
9.8 right here, that's that gravity value. And those two are up here. If it's in meters, we use 9.8. If it's in feet, we use 32. Okay. Any other questions? We talked about this first block. If you hit it 37 meters horizontally, would it even be in the court anymore? It's pretty far, isn't it? I don't know, 37 meter sticks. I don't know. Maybe like basically a yardstick. Maybe they're mad. Like, boom! Knock it out of the court. You've seen it happen. All right. A football. We don't have any football players in here, do we? Okay. If football is kicked from the ground at a 45-degree angle of elevation with an initial velocity of 60 feet per second. How long is the ball in the air? Okay, so it didn't ask for a picture, but I'm going to just draw a tiny little picture here. This is nothing special. Like the height is 0, 45 degrees, and then it comes back down. So it's going like that. This is 45 degrees. So that's our theta. Our height initially is 0 because it's on the ground, and our initial velocity v sub 0 is 60, and this is in feet, so for gravity we will use which number? 32. Okay, how long is the ball in the air? So it gets a little trickier. I'm looking for what? I'm looking for time in the y problem. Keep going, because I only need one variable that's unknown. So I want t to be unknown when y is 0. That's it. Okay, so there are 2 points when the ball's on the ground. Here initially, and here once it comes back down. And if I know how long it takes to come back down, then I know how long it's been in the air. Does that make sense? So I want to find t when y is 0. So I want to know when that vertical distance is 0, when it's on the ground basically, and how long is that? Now we're going to get 2 times. One is going to be 0, but the other one will be the answer that we're looking for. Okay, so let's take our equation for y. Flip back over if you need to see it. And plug in everything that we know, including y being 0. Okay, time is what we don't know. Initial velocity was 60. Sine angle is 45 degrees. Minus 1/2 times 32 is 16. T squared. And then technically there's a plus 0 out there for the initial height. Okay, I'm going to rearrange it, and this is when it will be handy to rearrange. Yes, ma'am. I put the t squared term first, and then the t term, and then the constant. So it's in descending order, basically.
Oh,
Okay.
So you could have put the t before.
Yes, I could put the t in front of the parentheses. Okay, and there's another significance why I like to rearrange these, and it's going to come to play right now. This is a quadratic equation. It's got a t squared in it. So the way that I'm going to solve this, I have 2 options. Factor. Do you think this thing's going to factor? It's not. I mean, look at that middle coefficient. If it doesn't factor, what do we use? The hint is on the board.
Minus b plus or minus the square root.
Which is the, someone said it, quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. If you need to sing it, sing it. But that is our quadratic formula. That's what we have to use here. All right, so let's get to work. So normally we'd say x equals, but our variable is t here. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Just your average little quadratic formula there. Now, if this is a 0 here, what is this whole product going to be? Yeah, that's all going to be a 0 right there. Okay, I mean, you can type it in, but I'm going to leave it out because I know it's going to be 0 there. Okay, now, I don't have a plus or minus key on the calculator, so I have to do this twice. Once with a plus and once with a minus. And sometimes it's hard to tell which is going to give you the positive answer and which is going to give you the 0. So I'm going to do it with the plus first. Yes?
Why is it negative 60 sign?
Because remember the formula is negative b, or the opposite of b. Okay, now, if you're thinking like, yeah, okay, just show me the answer, I want you to type this in your calculator, because this, believe it or not, is the tricky part about this problem. Getting it in the calculator correctly. So everybody, let's make a nice little fraction and get to work. After the angles for the signs, remember you have to close off the 45. So I did the plus one, and I got 0. I told you this is the hard part.
It's 0, right?
Yes, because it's at the ground at 2 times 0, and then whatever this other time is. So the other time is the one I want, but 0 is the correct answer to this equation. Oops. If you missed it, this is probably what happened. Go up. And make sure right here, make sure that the squared is not following the 45.
Yeah, mine was.
Because then, if it is, it's squaring 45 degrees and then taking the sine of it. So you've got to put 60 sine 45 in its own parentheses, then square it. So fix that and see if you get it right now. And then what I do is just go up and copy it and go back and change the plus to a minus. And then I don't have to type it all in.
Well, I got .0014.
That's still off. That almost sounds like you typed one number in wrong. Just check all your numbers.
Oh, the negative 60.
Okay, then I'm going to change it to a minus. Now I get the answer that I'm looking for, which is 2.65. After example 4, we're going to take a little bathroom break too.
What equation did you use? The horizontal or vertical?
The vertical.
Why did you?
The one with the t squared.
Yes. Why did you choose that one? Since it's like moving across the x-axis.
Okay, because the x equation tells me how far it landed out here. Like, oh, it landed 100 feet from you. But that doesn't tell me how long it's in the air. Well, it would if I knew how far it went. Then I could use that to find time. But I don't know that. So what I did is say, okay, really I want to know when it's back on the ground. Which means when is that vertical distance 0 again. Okay. Any other questions on that? The calculator, setting it up, anything? Okay, so now we know how long it was in the air. It was in the air 2.65 seconds.
Okay, I got the 2.65, but the 0 is still like...
Still not getting that one? Okay, well take your answer when you got 2.65. Go arrow up to the work, push enter, and backspace until you get to that.
Well, I just did that for the plus one. Like, I just did like...
Yeah. Emily, check her numbers. Just make sure all the numbers are 60s and 45s. That she didn't accidentally hit like 46 or something. And I'm saying Emily, check it because you've already looked at it. Like, it all looks right to you. So if you get fresh eyes, it's good. All right, don't clear it. I'll come back and look at it in a minute. All right, part B, find the total horizontal distance that it traveled. Now we are going to figure out, okay, so how far away from the kicker did the ball land? How far on the ground? But I know now that it's been in the air 2.65 seconds, so I'm going to use the horizontal equation and use t equals 2.65. So flip back over for your formula if you need to. It's t times initial velocity cosine theta. Yeah, it's times 0.
So all three of them are canceled out?
Yeah, because all of that's multiplied, and that's all 0.
How did that not affect the 2.65?
It probably did in some of the decimals a little bit farther out. At least we solved it. Emily solved it for us.
But it only looks like to 16 and 0 across the line.
Yeah, that whole product is 0 there. All right, so type that one in. And it went 112.43. Feet. Couldn't find it.
Took 2.5 seconds to 100.
Yeah. Pretty good, huh? But you think, I mean,
I feel like it would take longer.
you think 1 Mississippi, 2 Mississippi, almost 3?
The guy doesn't catch it in 2.6 seconds.
Okay, now 112 feet is how many yards? I would divide that by 3.
It's like 37 yards. That makes sense.
Okay, so if you picture 37 yards on a, yeah. So if you picture that, that seems reasonable.
So like 3 of them.
Uh-huh.
It's like 37.4. It's like kicking
Okay.
a field goal.
True. Mm-hmm. Good point. All right, let's do this one, and then we'll take a quick bathroom break. All right, a baseball player in the outfield. I know we have some softball players in here. Any baseball? No? Okay. The baseball... Go back over here. A baseball player in the outfield throws a ball towards home plate. The ball leaves his hand at a height of 6.5 feet at an initial velocity of 110 feet per second. Okay, so what do we know? The ball leaves his hand at a height of 6.5 feet. What is that? Initial height. Initial velocity is 110. It's in feet, so we'll use the 32 number. And what else do we know the angle? Don't. Oh, that's what we're going to be finding. Letter A. The ball is caught by the player at home plate after 1.8 seconds. So that's our T. If the ball traveled a horizontal distance of 191, that means that we know X. We know that horizontal distance. Find the angle of elevation at which the ball was thrown. Okay, so here's our X formula right up here. So X equals time, initial velocity, cosine theta. But I know that X is 191. I know that horizontal distance. I know time. I know initial velocity. But I don't know theta. Okay, let's go ahead and multiply those so that we can just get one simpler number there. 198. Okay, how am I going to get theta solved for? How am I going to get theta? Divide by 198. And then what? Inverse. Yes, remember when we're looking for the angle, that's when we use inverse. So theta will be cosine inverse of 191 over 198. Cosine inverse 191, 15.3 degrees. That's a small little angle. That'd be hard to do, wouldn't it? Throw a ball at an angle of 15? Well, I guess you're raising it up, so it probably wouldn't be. Never mind. I assume it's raised up because it's leaving a height of 6.5.
Because if they throw it up like this, then the ball kind of goes away from your hand when you throw it, so it's like...
Yeah, I don't guess you would throw it real high. Like a real big angle, it would be kind of flat because you're trying to get it straight across. Okay, part B. What was the height of the ball when it was caught? Okay, so if we're looking for height, we definitely need the y equation. We know the angle now, so we should know everything for y equals t v sub 0 sine theta minus 1/2 times g, but it's in feet, so that's 1/2 times 32 is 16 t squared plus initial height. Is everybody okay where I got 16 from? Okay, so let's plug it all in. We want to know y. Time was 1.8. Initial velocity was 110. I now know the angle is 15.3 minus 16, 1.8 squared plus 6.5. And let's see if we can all type that one in correctly, myself included. Get 6.9 feet. He was stretching, wasn't he? But I guess if you're about, you got a negative?
Yeah.
It went underground.
I
Okay.
think I tried to rearrange it and it did not.
Okay.
Should the square put inside the parentheses? I can't say that word, but 1.8.
That one wouldn't matter if it was inside the parentheses, because you're only squaring the 1.8.
I don't know what it called it.
Let me look.
I mean, if anything, I thought I would have, like, I put more. I can't say that word.
How about just say brackets?
I'll say brackets. Yeah, I got it without.
Oh, okay. So you had an open parentheses there that you didn't close. See how you just went on. So here, let's insert one more.
Insert. I always go visit Elise.
Oh yeah, use insert. It saves you
On
time.
Friday, do we go to Veterans Day program?
It's first block, so no.
But no, like, do we actually go? Like,
The seniors are going to the Fine Arts Center to watch it, and the rest of the school is watching it on the screen.
what is it?
The Veterans Day.
They did that too last year.
I don't know why they've changed it.
Every year it's different.
Yeah.
Well, the year before last was because of COVID, and it was like only the veterans in the fire. Yeah, but last year we did it, and then last year we did it.
I don't. Maybe it's just because the seats are more comfortable for them there. I mean, most of them are older, so maybe they're trying to give them comfy seats. Okay, so this ball was almost 7 feet high when he caught it, which if you're a 6-foot player, I guess that's not too much of a stretch, is it? Okay, let's take a quick bathroom break, and then we'll tackle number 5, which is the hardest one. Okay, last problem. A projectile is fired from the top of a 24-meter tall building at an angle of elevation of 28 degrees with an initial speed of 55 meters per second. Okay, initial height is 24. Theta is 28 degrees. Initial velocity is 55. Okay, so this one is in meters, so when we do gravity, we'll use the 9.8 number instead of 32. Okay, what is the maximum vertical height reached by the projectile? All right, so let's draw a picture here. I have a building. Here's the ground, and this is 24 meters tall. And the projectile is being fired from the building with an initial angle of 28 degrees and velocity of 55. Okay, so we're starting up off the ground. This path that it travels is parabolic, isn't it? Okay, so it's going to go up, hit some maximum value, and then start its path downward. So how am I going to find the maximum vertical height reached? I want to know when y is at a max. It has to do with it being a parabola. What is this point right here where it reaches its maximum height? The vertex. If I could figure out the vertex of that equation, then I would know when it reached that highest point and what the highest point was. Okay, there's a little handy formula that you used in Algebra 2, I guess. The x-coordinate of a vertex can be found with negative b over 2a. Does that ring a bell? Negative b over 2a gives you the x-coordinate of a vertex. Then to find the y-coordinate, you sub that into your function. Okay, that's what we need to know. Okay, so we're dealing with the vertical equation, right? So let's write that. Y equals t VO sine theta minus 1/2 GT squared plus H sub 0. Okay, so my equation is y equals t, I don't know. Initial velocity is 55 sine 28 degrees minus 1/2 times 9.8 will be 4.9 t squared plus 24. Now I'm going to rearrange it because I need to pick out the negative b and the a value. So this is negative 4.9 t squared plus 55 sine 28 degrees times t plus 24. So this is A, B, and C. If I had to use my quadratic formula, or I don't need the C here, I just need negative B over 2A. Okay, so the t value, which is like saying the x value, is negative b over 2a. Can y'all see that formula at the bottom? There it is down there if you missed that. Negative b over 2a is what I'm using to find that x-coordinate. Okay, so let's plug that in. .63. And what units is that? Seconds. Okay, so I didn't answer the question yet. All I figured out was what is the time when it's at this highest point. Okay, so the time that it's at the highest point is 2.63. Comma. Now I've got to figure out what that height is. So I'm going to plug this into t in the equation above. So this time here is going here and here. So subbing those in for t. All right, let's see if we can get that. Oops, I want that one. All right, negative 4.9 t squared plus 55 sine 28 times 2.63 plus 24. Get 58. 58.02 meters. Okay, so basically what I had to find was the entire vertex to answer that question. I had to find the x-coordinate and then the y-coordinate of the vertex of the parabola to know what the highest vertical height was reached. Any questions on that one? That one's a little tricky. Okay, part B, find the horizontal distance at the same time when it was at that maximum height. How far had it traveled horizontally? Well, that just means find your x value, your x equation value, when time is 2.63. So find x when time is 2.63. Okay, so x is time, initial velocity, cosine theta. And not really anything tricky about plugging that one in. So it's gone 127.72 meters horizontally. Question on that? Okay, last part. If the projectile is fired towards a taller building that is 300 meters away, so that means horizontally away, will the projectile hit the building? If not, how far from the building will it hit? Okay, so what do I want to know here? Yeah, so kind of like with the football problem up here. I want to know how long it takes to get back on the ground. And this one didn't start on the ground, so I want to find out how long it takes for y to be 0. So find t when y is 0. I want to know how long it takes to get back to the ground. Then, once I know that, then I can figure out how far horizontally it traveled. Okay? Alright, so it's going to be another situation like this one up here where we have to use quadratic formula. So if you messed up the first time, you get another try at it. We want to know when y is 0, What is t? How long did it take to land on the ground? Okay, so our equation will be t times 55 sine 28 minus 1/2 times gravity. So 1/2 times 9.8, 4.9. Actually, I already had that equation up here, didn't I? I don't know why I'm writing it again. There's my equation. Right there. Okay, so now I do need A, B, and C. So this is A, this is B, this is C, and I'm using the quadratic formula. Negative B plus or minus square root B squared minus 4AC all over 2A. All right, here we go. Okay, C is not 0 on this one. Whew, all right, let's see what we get. Oh, I got a negative 0.8. Is time going to be negative? No. Do you see why I got a negative 0.8 though? Because remember, this started above ground level. So if I were to continue that parabola backwards till it reached 0, that would be representing this negative value. Okay, so I did get a negative, but of course we're not going to use that. So let's see what the real answer is going to be. So I'm going to go back and change this plus that I had in front of the radical to a minus. And there's the answer that we're looking for, 6.08 seconds. Okay, but that doesn't answer my question. That tells me how long it was in the air. So I want to know, did it go 300 meters away from where it started? So that's that horizontal distance that we're referring to. So I want to find x when t is 6.08 and see if it went this 300 meters or not. Okay, so x equals 6.08 times initial velocity cosine of the angle. Okay, so let's find x. 6.08, 55 cosine 28. It went 295, oh so close, 0.26 meters. So did it hit the building that's 300 meters away? No. If not, how far from it was it? It was, how close? Subtract 300. It was 4.74 meters short. from the building. Question. Okay, so I have 6 problems for homework for you. The last one is very similar to this one. So I'd probably start with this one because it's the hardest and it's fresh on your mind. So let me get those out to you.
How many of those like that will be on the quiz? Do you know?